Let's begin with what you already know, a linear equation in one variable. It has the form ax plus b equals 0, where a and b are real numbers and is not equal to 0. Every linear equation in one variable has exactly one solution. For example, 2x plus 4 is equal to 0 gives x equals -2. But when the highest power of x becomes 2, we enter the world of quadratic equations. The general form is ax squared plus bx plus c equals 0, where a, b, and c are real numbers and is not equal to 0. This is the standard quadratic equation. So, linear equations give one solution, while quadratic equations may have up to two solutions. A quadratic equation is any equation that can be reduced to the form ax squared plus bx plus c equals 0. The coefficient must not be 0, otherwise the x squared term vanishes, leaving a linear equation. Examples: x squared minus 3x plus 2 equals 0 and 6x squared plus x minus 1 equals 0. Both are quadratic equations because the highest power of x is 2. And importantly, their solutions may be real or complex numbers. A root or solution of a quadratic equation is a value of x that makes the entire equation equal 0. Condition: a alpha squared plus b alpha plus c equals 0. Each quadratic equation can have at most two solutions. Sometimes they are distinct, sometimes repeated, and sometimes complex. So, roots are simply the values of x that reduce the quadratic expression to 0. Let's check with an example. X squared minus 3x plus 2 equals 0. Substitute x is equal to 2. That gives 2 squared minus 3 times 2 plus 2, which is 4 minus 6 plus 2 is equal to 0. Perfect. X is equal to 2 is a root. Now substitute x is equal to 3. That gives 3 squared minus 3 times 3 plus 2, which is 9 minus 9 plus 2 is equal to 2, not equal to 0. So, x is equal to 3 is not a root. This shows how we can check roots by direct substitution. How do we know in advance what kind of roots we'll get? That's where the discriminant comes in. The discriminant is d bar b squared minus 4ac. If d is greater than 0, two distinct real roots. If d equals 0, one repeated real root. If d is less than 0, two complex roots. So the discriminant is like a shortcut to predict the nature of solutions. Let's solve and classify roots for 6x squared plus x minus 1 equals 0. Step 1. Compute the discriminant. Delta is equal to b squared minus 4ac, that is, 1 squared minus 4 times 6 times -1, which is 1 plus 24 is equal to 25. Since delta is positive, we know there are two distinct real roots. Step 2. Use the quadratic formula. X equals open bracket negative b plus or minus square root delta close bracket divided by 2a. Substitute values. X equals open bracket -1 plus or minus square root 25 close bracket divided by 12. Now evaluate times first root. X equals open bracket -1 plus 5 close bracket divided by 12, that is 4 divided by 12 is equal to 1 by 3. Times second root. X equals open bracket -1 minus 5 close bracket divided by 12, that is -6 divided by 12 is equal to -1 by 2. So, the roots are 1/3 and -1/2. Let's recap. Times linear equations have exactly one solution. Times quadratic equations have degree 2 and can have up to two solutions. Times roots are the values of x that make the quadratic 0. Times substitution helps us verify if a number is a root. Times the discriminant, d squared minus 4ac, decides the type of solutions. Times using the quadratic formula, we solved 6x squared plus x minus 1 is equal to 0 to find roots 1/3 and negative 1/2. Quadratic equations are more than just algebra. They model real-world curves, projectile paths, and even structures in engineering. And that, students, is your foundation for quadratic equations. In the next video, we'll dive into solving quadratics systematically using methods like factorization, completing the square, and of course, the quadratic formula.